Alright, good morning, boys and girls. Nathan, as always, says action. Now we're ready to get started. In 8th grade math, we're finishing off our unit on scatter plots and statistics by using scatter plots and the lines of best fit to make predictions. So here's a sample scatter plot.
Also, you can just subscribe or like
Okay.
if you want.
Nathan with the plug. Now, in this scatter plot, we're tracking a population of a certain species over time in thousands, and the population each year seems to be, in general, decreasing, with some going up and down. Now, we're going to use this to make some predictions. Now, one thing we can do to do this, it seems that a general negative trend, is to draw in a line of best fit. So, like, one prediction we can make based off our line of best fit.
Tell that it looks like a triangle.
Yeah, it makes a triangle style picture, Nathan says. Is how long until the population is gone? Well,
so
our line crosses about there, so
this
1,
number
2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it looks like it'll be gone in about 13 years. One thing you'll be doing more specifically, okay, write down, Nathan, is what would the population be in year 5? Well, if we go to year 5, 1, 2, 3, 4, 5, and go up from there, and look at that, the population will be approximately 5,100 or 5,200 or so. Will this answer be perfect? No, but it will be in the right reference. Yes, Nathan?
100.
Okay. Keep moment there for you. Another thing they could ask you is approximately what is the slope? Well, the slope seems to go down. That we already determined that this is about 13. Right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And it goes 1, 2, 3, 4, 5, 6, 7, 8, 9. So negative 9,000 over 13 is about the slope in this case. So that implies to me you lose about 800 or so each year. If you actually want to do the calculation. Don't ask me what my child is doing. I don't know either. What are you doing, Nathan?
Funny.
Being funny? Yeah, makes sense. Okay, that's negative 692 approximately. So it looks like on average this population of whatever it is, deer, rats, people,
So
who knows,
what number
loses about 692 each year. Okay, so that's one kind of prediction is using the scatter plot. Now the other problems in the assignment will be using equations. Oh, sorry, Nathan, you want to erase it for me?
Oh boy. This is the first time I erased 100 stuff. 1,000.
Why it's 100,000 stuff, I don't know either. Now we're going to say, given an equation, we're going to make a prediction with the equation. Alright.
There's some black marks
Suppose that a question that could come up in your assignment is you're trying to get your 100-yard time down. And each day, let's say each month you train, you can lower your time because you're trying to get the time for the 100 yards slower. If you start at, suppose, 800 seconds, I have no idea what this would actually be in reality. I'm just going off a question to answer things like this. And you lose 5 seconds for each month you train. How long will it take you in 10 months? Well, to solve that kind of problem, and make sure you can see this, negative 5 times 10 plus 800. That gives you negative 50 plus 800. So your y value is 750. 750 seconds to go. I said 100 yards. And I just realized I answered 11 minutes. Sorry, over 12 minutes to go 100 yards. You are apparently extremely slow. So this 100-yard time doesn't make sense for this problem, but still the same type of method does work. So most of these problems, you plug in an x value, solve for the y. Will it be 100% perfect? No, you're approximating based off the data you have. That's what statistics does, is they approximate data. Based off the data we have, here's our best guess. It's better than nothing. It won't be perfect, but it gives you a solid basis to go off of. Thank you, and as always, ask me questions.